going to do this a little bit slowly so that in this way people can see what I'm doing, what I'm doing, what I'm doing. Here I'm making a circle. The radius of the circle is not 1, although I did put 1, but I'm going to change that in a few seconds. I might sound a little bit boring right now. It's because I just woke up. Bear with me. Yogi with me. Yogi bear with me. uh, okay, I'm just gonna get this grid off. Damn, that thing is on the way. And we're going to change the value of the radius from 1 to 2 times the square root of the golden ratio. So that would be the golden ratio, which is 1 plus the square root of 5 divided by 2, giving you the golden ratio, which is 1.618, but you can round it to the 6th decimal and just say 1618034. It's still the same. And after that, we're going to do square root, which gives us 1.272. And we multiply this by 2, so that in this way we get a radius of 2.544. Now the reason why I'm going to do this is because it's going to produce a pyramid with a base of 4 and 4 exactly. Now just below, we get to see, god damn it, that's not what I wanted to do. Okay, so I'm back, I guess. Do I still got that? Am I still connected? Yes, I'm still connected. Okay, perfect. So that's out the way. Okay, I'm just gonna lock these so that in this way I know that no modifications can be done to the circle. I want the circle to remain exactly as is. And also I forgot to mention that the circumference of the circle here is wrong, and I'm going to show you the reason why it's wrong. Because, well, for one thing, the greater majority of scientists and scholars, academics out there, they're not too sure on the exact value of the number pi. But a square, it's always a fixed value, and a triangle is always a fixed value. And if, however, from a circle you get a square and a triangle of a fixed value, then this would probably mean that there was an error in the circle itself, if ever the circumference of the circle is not exactly the same as the perimeter of the, let's say, the square, or the circumference is not exactly the same as the area of the triangle. But for the latter, it's a little bit tricky. you need to do this with a very specific number, if I do remember. I would have to do that one time on in another video. Sorry. So what I'm going to do, I'm going to use Samuel Samuel Boy's formula to create what he dubbed the the perfect symbol. And so to create a perfect symbol, you have to start with a circle of any radius value. In this case, in order to prove my point, um, it's going to be of a radius value of 2 times the square root of phi. And afterwards, I create another circle, okay, which intersects with with the first circle, so that in this way it creates a Vesica Pisces. And I do the same thing with the next circle. That's perfect. From there, we have 3 circles which are connected to one another. To that point, the second circle we don't really need anymore. It's really just the first one and the third one, okay, that we would need. But for no, actually, okay, we do need the second circle, because as you can see, the second circle produce reveals the center of the third circle. So we're gonna need that, and then we're gonna create a line from the base of the first circle up to the center of the third circle. And from there, yes, now we can delete the second circle. And that's where we're about to start the magic, because the circle which I'm creating, if I do remember, it is, let me see, you see, it shows the number pi, like right there, right? You see that one here, and that's the one that I'm clicking like over and over. And the reason why it's the number pi right here is because, well, I'm just going to do the equation for the number pi. Number pi, um, based upon the golden ratio and not this pi. This pi is the pi that all scientists, scholars, and academics, they agree upon. And so I don't agree upon it. First and foremost, it does not come with an equation, and because it does not come with an equation, they dub it as transcendental. Like, yeah, it's like it pops out of nowhere, you know. And I do not agree with that premise, unfortunately. So, but I did manage to find another pi uh, from one formula, and it was really just by accident. And I read it in the book, which is known as the quadrivium, and in it they were talking about this number pi, which is 3 dot 14 16 41. And the way I got to this number was by doing 3 divided by 5 multiplied by 3 plus the square root of 5. Yeah. And it gave me that one, you know. But what I found interesting about that one, and even like with the so-called transcendental pi, was that if ever you were to multiply it by uh, uh, how do we say this in fractions? 5 divided by 6, 5/6. I guess. 5 over 6. So basically, it's that one right here, yeah, multiplied by 5 over 6, giving us the golden ratio squared. You have got to appreciate that. It's really beautiful because I mean the golden ratio, its magical properties is that when you do the square root of the golden ratio squared, it gives you the golden ratio, which basically is the golden ratio squared minus one, you know. And if ever you were to do one over the golden ratio, it would give you the golden ratio minus one still. Yeah. So that's why the golden ratio it's a beautiful number because it's well balanced the way that I see it. But out of this number, if you do the square root of the last one that I just did, and then you multiply it by 4, it reveals the true number pi, which if we go back again to the illustration gives us that one right here. Yeah. But that here is really just the template for the rest of what I'm going to show you because, as I said, I want to show you the base of the pyramid, which is created out of this setup right here. So I'm just gonna take off that circle right there, and I'm gonna take off, yeah, that guy I'm gonna call after, after, after. Yeah. Everybody wanna know, after. I'm asleep. For now, I'm asleep. I'm gonna call you back. God damn it. Yeah. So, and I'm going to remove that line right here. And then after that, I'm going to create that triangle right there. Okay. So it's not the full base of the triangle that's going to show you the number 4. It's really just one portion of it. And the portion in which I want to show you is it's not necessarily that one, but we're going to look at that one afterwards. It's mostly, well, we can still look at that one as a matter of fact, and the reason why we can look at that one is because the hypotenuse of it, it shows the number. It's supposed to show the number. Let me see. If that's 2, that's 4. It's supposed to show you number 4, as a matter of fact. Let me see. And you see, I was right. Shows you the number 4 right there for the hypotenuse. You know. So this means that if we were to uh, check the number right here for that triangle, this would mean that the base of that triangle right there is number 2. Neat, right? So this would mean that if we were to make like a square, yeah, like a tiny square right here, yeah, this would mean like that, okay, that the square, the perimeter of the square, it would be 8. And so if ever we were to do 8 divided by 2 times, well, divided by 4, well, 2 times the 2 times the square root of 5 times 2. There we go. Wow. Took a long time for me to figure that one out. But if we do that, And taking into consideration again that the square root of phi multiplied by 2 is shown to be the radius right here of the radius of the circle. Yeah. So this would mean that in doing this equation, it would be as if we would be doing the reverse equation of 8 divided by 2 multiplied by pi. So this equation right here, which I'm going to do, I'm just going to remove all of that again, is going to show you that this is going to reveal the true number pi. Yeah. So I would, and we know, okay, that it would be 8. The reason why it's 8 is because uh, the blue square right here, yeah, is only 1/4 of a huge square. Now let me show you like the huge square I'm talking about. Yeah. The huge square that I'm talking about, I'm just gonna do it like this and like that, and I'm pretty sure you've all seen that symbol before. If I were to take off these and take these off, and goodbye the triangles, and that form right here is known as a squaring the circle, you know. And you have to remember that all of this came out of one circle. So this means again that the circumference of the circle itself should be exactly the same as the perimeter of the square. But the perimeter of the square here is shown to be exactly with an area of 16 and a perimeter of 16. And so normally the circumference of the circle should have been 16, and it would have resolved at the same time the uh, the problem about the area and the circumference, you know. But that's something that people would need to research a little bit, because it seems that um, there are two ways to square the circle. One by which you need to have if I'm not mistaken, it's either the area of the square with the circumference of the circle, or the other way around, I don't remember. But the one that's popular to me is the circumference of the square, the circumference of the circle with the perimeter of the square. And that's the one again that we're looking at right now, because that's the one that, in my opinion, is the most important, you know. So, and as you can see, it shows here that the radius here is 2, like right here, you know, it's 2.544. Now if I go back to this here, I know that um, the perimeter, okay, I know that the perimeter of the square, of the small blue square, it is 8, because the side of it is 2. So 2 times 4 is 8. Yeah. And I know that the perimeter of the full square is 16. And we just seen that a few moments ago, okay, by uh, on there right here, you know. If I go back again, no, it's showing right here. And for your understanding, quadrilateral, that's for square. Circle, of course, is circle. But you see the position right there where I took it. It's where you have like the exact number 2. And right next to it, you see that's half number pi. Yeah. But if that's half the number pi, this circumference right here is wrong. The area right here it's wrong. Yeah, and it shows that the equation for that is this based upon the radius right here. And if I do take this multiplied by 2, it gives us, okay, like the parameter with which is 16. And let's do that, divided by twice the square root of 5. So twice, 2 times the square root of 5. So I'm just gonna put 2 times again, and then the square root of 5. So I have to create 5. So 1 plus the square root of 5 divided by 2, and then I do the square root, boom, boom, and it gives us this 16 divided by 5.0880785. I do equal, and it gives us the real value of pi based upon that which normally, based upon the perfect symbol, which is derived from the template of Samuel LeBoy. I suggest again that if ever you have a chance to do this, to go on the YouTube channel of Samuel LeBoy. So it's Samuel LaBoy, not Samuel L. Jackson, Samuel LaBoy. And you can like write down like perfect symbol, okay. But the thing is that Samuel LeBoy, though he did like use the perfect symbol, okay, like to do his template, and that's the second one. The second one, okay, is the one I prefer. uh, as you can see, he like that's one of my videos on the third one right there where it says irrefutable proof, but still that's not what we're talking about. Samuel LeBoy, he has like this video that says the circle and the perfect symbol. And on that video it shows you like you see in a preview, the circle and its magic, and the triangle also, and like all the measurements, and if I input the triangle on this one, the last one, not that one, that one, you see, that's like the perfect symbol, you know that's what it is. That's what the perfect symbol is all about. And it reveals a whole lot of secrets, a whole lot. Like, let's say for example, if I were to take like that green triangle right there, that we produced out of that perfect symbol, you know the degree for the angle, okay, for that triangle is exactly 51.8273, you know and although, and that's one weird thing, I don't know, okay, if that's the exact number or if it's wrong, but if ever, okay, you were to take that pi divided by 2, by 4, sorry, and then afterwards you do the like inverse sin, in degrees, it gives you that exact degree: 51, 82, 72, 92, 37, 299, you know and what I like about this calculator is that it allows you to show you the proof of it. So if I were to take number pi, I'm just going to put it to the sixth decimal because it's getting tedious to my eyes. You take pi, then you do the Pythagorean theorem. Well, that's like the sign, that's the angle sign for that. You can change it to degrees or rads or grad. I'm just going to keep it to degrees because this one comes up as a degree, you know and after that, okay, you can get like the real number out of it, which is 194. Yeah. And you can get the imaginary number. Yeah, that's right, the imaginary number, which is 247. And what's special about these two is that, let me go back with this one. I take pi divided by that one, it gives us phi right here. And if ever again I were to take that one multiplied by 4, no, let me do that here. Take that one multiplied by 4 and then square root, it gives us pi here. And I can even like take the pi right here and go back. Yeah, it's crazy, I'm telling you. But going back to this, that's my little presentation on the true value of pi and the magic of it and what it reveals and the errors in the conventional pi, which absolutely need, like, the academics, okay, they need to change that like ASAP. In 2018, I heard, okay, that the symposium for like like the measurement thing in France. I don't remember what it is. Uh, I don't know if it's in France or in Geneva. I don't remember, but it's a convention for the measurement of the kilogram, and they still calculated it with the same flawed number pi. So I mean, the advancement in technology and whatnot, it may be impressive right now, but it will always come with an error. There's not going to be any consistency. There's not going to be any balance. And I mean, let me take this off, man. I have this in like that. I like that one. That's what I like there. But really, yeah, like you need to get like everything straight, correct, and just to make sure okay, that you understand how perfect this symbol is. Like, check this out. There's an intersection here that goes right there and goes down right here. Yeah. If I were to make a circle from the center to here, this circle is snuggled, like it fits perfectly inside of the pyramid. It's crazy. It fits perfectly inside of the pyramid. You can take this off, like you can take off like the square and the pyramid, and you have like, you see, like I don't know if you see this. The radius is half pi. The radius is half pi. So if, well, just for just before I conclude this completely, okay, there is a way to get to pi. It's simply to do 4 divided by the square root of phi. That's it. It doesn't need to be that complicated. Once you know the equation, okay, you get there, you know. But check this out. Divided by 2. Yeah, that's the radius. So I take the radius multiplied by 2 multiplied by phi, and it gives you the square of phi, you know. And so the square of phi would be the 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 circumference of that circle. So if I click on the circle and I go to the metrics, what it gives us is something totally different, 9.8791. But down there you see the equation, which is the square of phi divided by 4 right there. It's messed up. That's bad programming, you know. If I go back there, divided by 4, badal, and I can put it to the 4th decimal right here. Not that, but to the 4th decimal, 247.21. You can see that. And if we go back here and we check like the metrics where it says equation 247.21, yet the circumference is 9.8791, which makes no sense at all. That's probably the reason why we're not moving forward. We don't agree on like looking for evidence of stuff, you know? We just want like the invention. We want the fantasy. We want the glamour. Glamorous. Yeah, you know, that's all they want. The glamorous. But still, when they come to realize that what's more important is not what's invented, it's not what's believed, but it's really what you know and what you can see and what you can prove, then there's going to be a change in the reasoning of mankind. Right now, again, the reasoning of mankind is not going towards progress, it's going towards control, like controlling your mind into believing something that is not. Like the let's go back to the transcendental number pi. Okay? I said like that again that pi squared divided by 4 should give us 2.47 based upon the equation which is right there in the geometry pad, you know? But it gives us 2.4674. That's wrong. You do 4 divided by pi, which would have been the reverse of 4 divided by the square root of phi. It should give us the square root of phi, which is not the case. And I showed you that you could use pi and multiply it by 5 over 6. It would give you phi squared. Here it shows you phi, but you change the decimal, it shows you something else. You know? If ever I were to take that one right here, yeah, and do the square, that's not phi. And if I do 1 over that number, it may look a little bit like if ever you do plus 1, it may look a little bit like the the constant, the Planck's length. It looks a little bit like that, but it's not it. You know, remove that. But still, if I do the square root of that multiplied by 4, it would give us something that looks a little bit like, what am I looking at? Let's do that one more time. That's interesting. That is perfect. Well, not so perfect because it stems from the conventional pi. And we know it's not perfect because we've already established that it does not comply with the perfect symbol. And so in the perfect symbol, all the numbers are revealed, shown to be revealed right here. And so there doesn't seem to be any type of mistakes. If I were to remove that one and put back this and put back that, you see here everything fits like it's snuggled, you know? And of course, for those who are really into like the square root of 2, then if we were to do the circle like all around the square, so that would be 2 times the square root of 2, man. That's intense. The like that circle is way too perfect. So going back here, that here got me a little bit puzzled. If I do that, and then if I do that, and then I'll do that, and then multiply. That's some weird ish. Hmm. Let me go back. If I take one, okay, one, okay, let's go back. We got that one, okay. Um. Oh, I see. I did the whole sequence multiplied by 4, but it's still the same thing. If I take that one multiplied by 4, but that's weird. I take that one though. It doesn't give back the same as that one here if I do square. So that's two different. This one will relate to its origin, its weird origins. It shows two pi's. Well, two phi, sorry. Let me redo that again. Multiply. That's one phi. And let me do that again. That's two phi. Two very different phi's. We all know there's only one, which is 1 plus the square root of 5 divided by 2. That's the d phi, because when we've already explained when you square it, it gives you this. And when it's 1 over, it gives you that. It doesn't change. If you were to do the same thing with that one, square it, it gives you that. That's wrong. 1 over, that's wrong. Same thing with that one. Wrong. 1 over, wrong. And like the ultimate of ultimates, that's the one thing that I like. Um, let's say, for example, that as of the template right here. Yeah. Let's say that the the triangle right here. What you see where it says 2.54. Uh, if that portion, instead of saying 2.54, it was 4. Okay. Then the base where it says 2 should be pi. You know. And so the way to prove this is that if I were to take 2 multiplied by uh, the square root of phi divided by 2, it gives us this, which logically it should give us like the square root of phi. But that's the thing. That square root of phi is like the template that you need to get pi. So if you do 4, if ever you were to think that the radius of the inner circle, let me remove some circles right there. Remove that, remove that, remove that, remove that, remove that, and keep that. Okay. So if ever the 2.54 was the radius of the circle, and you change that 2.54 to 4, so you would have to do 4 divided by the square root of phi, the square root of phi, in order to get pi right there, you know. And I'm just going to save this. I'm just going to do a new one, save. Press. Okay. New one. The one I'm going to do is going to be of radius of 4. Okay. So this one is going to be a radius of 4. Okay. I'm just going to redo the perfect symbol like I did earlier in this presentation. Right here. Make this quick. We don't need to get to like go through the hassle of explaining what we've already explained before. Okay. Originally in the video from Samuel Leboy, when he creates the perfect symbol, the way I did it with a shortcut. But the way that he does it is that he uses like circles to like create the square around that square is a circle, because the premise is that in order to get to truly square the circle, like you cannot move away from like the original template, like the original circle. You need to like continue from from where you started. You know what I'm saying? So uh, from there, okay, I just create the square right there. It's rather easy this way. Not faster, but easier. The fastest way is the shortcut that I'm using, where I just create two small square and then one big square, following the principle of the golden ratio. So now that we have all of this, I'm just going to remove, no, I'm not going to remove the lines yet, but I'm going to make sure that they're all locked, so that in this way, when I'm going to create that one triangle that's going to reveal what I was talking about, let me put like a joyful color, blue, color of truth, right there. So, as I was saying, the radius now is 4. So, radius is 4. Yeah. And I did say that the base of the blue triangle is pi, right there. So it complies with the fact that if you do 4 divided by pi, it gives you that, and that multiplied by 2, it gives you the previous radius that we had earlier on. Let me save that one. Save true pi. Okay, and let me open the other one. Press right there. You know. So you see, that number 4 is not supposed to be there. It's just a glitch of the application. As you can see, I just moved it and it's already gone. But as you can see, if I put back the square right there and the triangle, the template's still the same. Still the same template, you know. And if I go back to the other one, the true pi, right here, and I check for the angle is exactly the same. It doesn't change. It does not change. And to make this even more interesting, the hypotenuse is basically 16 divided by pi, which we've covered earlier on, right there. You know, the side, the side of the triangle. My God, the side of the square, 2 pi. Yeah, and that 2 pi can be found also on the side of the on the longer side of the triangle. 2 pi. So if I were to do, let's say, uh, because it's a full one, and then multiplied by 4, should give us 2515, which, if I unlock the square right there and we check the metrics, we see the parameter shows 2515, you know. But if we make the comparison between the circle and the square, here the circle shows 2513, which is a mistake because we've already established that, you know, the radius is 4, the equation that we had is the 16, everything is correct there, but that is not correct, and that surely isn't correct if that is not correct, you know. But the parameter for the square, because squares, they are fixed numbers just like triangles, so they're always going to give you like the correct result. It's 2515, and the area is 3955. And the reason why it's correct result, as mentioned previously, it's a square. But what makes it more interesting is that this square was born out of a circle, to which a circle has a circumference which is not equal to the square, which does not make any sense. I mean, do we need to cry it out loud? You know, these were like, I'm pretty sure you could find this in the Rhine Papyrus, like all the explanations. That symbol in itself resolves a whole lot. I'm not going to say too much. I think that in my previous videos, I did mention something about time and whatnot. But, oh yeah, one more thing. Um, if you do, uh, if you do pi divided by phi, yeah, by the golden ratio, yeah, it gives us that number, yeah. And if ever I was to multiply 4, which is the radius right now, by that number, it would give us 7.7777. Now, that 7.7777 in this figure right here is the full base of the pyramid. So if I take green color of revelations, yeah, and then I show the length, 7.7739. I can add up like the decimals, so we can see clearly 7.773892, 7.773892. I mean, it's all there. It's all there. And there's only one mistake. One mistake. And that's the number pi. And that number pi, okay, that all the scientists and all the scholars and all the academics have been arguing for so long. I don't even know why they've been arguing. It's wrong. I don't even know why, okay, they're chasing after the infinite number in that number. Oh, I have found 1 billion digits of that number. I have found 10 billion digits of that number. Let me show you, okay, why this number right here, the 3.144606, is the number, you know? Um, the number 4 is the radius. Yeah? And if ever it's the radius, multiply it by 2 and then multiply it by pi, it gives us the circumference which we saw earlier. Yeah? I said I was going to conclude this, but it seems I'm not concluding anything. I'm pissed. So we got the radius right there. Yeah? After that, if ever we were to take that circumference and divide it by 8, and I'm saying 8 and not 4, if I were to do 4, then this would simply imply that the number 4 itself is not the radius but the diameter. And then at that point, I would simply do 4 times pi equals this. And then I would simply do divided by 4 for the square so that I would get the side of the square, which basically would be pi, you know? But because above I have it 4 multiplied by 2 multiplied by pi, yeah, it implies that there was a division. The number 4 is no more a diameter, it is a radius. And radii, like two radii, one radius, two radii equals one diameter. One radius is simply one radius, but two radii equals one diameter. You need to remember that. And so, because of this, you need to divide it by 8 because the square is larger. You see? Now, it is beautiful to see that this circumference and this circumference would show up to be like, in the mind of the scientists and the scholars, like the square of the circle, but it's not. The reason why is because the proof is found in the Pythagorean theorem. In the Pythagorean theorem, if you do 4 square plus pi square, which basically would be the radius plus half the base of the triangle, both squared, it would give us this number, which normally would have been the hypotenuse that I showed you right there. You know, should be like the hypotenuse right here, but it's not. Yeah. And so the reason why it's not is because afterwards, and that's the beautiful stuff, if we were to take that number and multiply it by pi, it does not give us 16. The goal of this equation is to go back to 16, you know. It will give you 16 if you were to do the reverse of the Pythagorean theorem for this one without any problems, you know. But that one right here does not give you 16. It gives you something else. Getting back to the true number pi, the one which was found on the perfect symbol, the one which is bound to all the figure. If we go back to that one and we do, you know what? I'm going to show you the full equations just so that in this way you can understand exactly what I'm talking about. 4 squared divided by pi. And you see that. Now that's the 16 divided by pi. It's not the 16 divided by the hypotenuse. So divided by pi gives you something totally different than what we did when we did the 16 divided by the hypotenuse, which was at the time 5.086. Instead, it gives you 5.092. Still a whole lot of flaws with that one. We're going to square it. Minus pi squared. And you see it gives us somewhat of a 16. Now, this is like really final because after showing you this, after showing you again, like all there is again, like on this figure itself, again, there is no way again, that no one would not want to do any more research on that. Oh, I did do something though earlier, and I found this neat. I just want to see exactly what's the radius of the inner circle snuggled in the in the triangle. Mm, let's see, circle metrics. So it does. Huh. So it shows that the radius is the square of pi divided by 4. But we don't need to concern ourselves with the circumference. We already know that it's wrong. But the equation here is not wrong because that's the square of that right here. So if I do square it, you see that's perfect. But that here is wrong. Yeah. And we already know it's wrong. We have the proof right here. No, we don't have the proof. I'm going to show you the proof. So 4 divided by the square root of phi, yeah, giving us the pi that we need for this equation. And now we do 4 squared divided by pi. We square minus pi. I mean, I would do a President Obama and simply drop the mic. Or I would do like in a cartoon and simply say enough said. Who says that? Wolverine, I said. Enough said, Bob. I mean, come on. You have got to appreciate. In anyways, that's the 9 prime, and I bid you farewell. See you for another adventure of the true value of pi. Yeah, check out these people, Ari Lair, Samuel LeBoy, Billy Meyer, Panagiotis Stefanides, Giant 108. Yo, guys, you have got to check these guys, man. They know something that you don't, you know. And so maybe they're not like I don't know here about like their education. I know for myself, I was bad at math, like really bad at math. But there was a reason for that. I was pissed at the fact that there was a number that had no equation whatsoever was called transcendental. I needed the evidence for that, you know. Took a lot of research, but it paid off. Once you found again what you're looking for, again, it pays off. So peace. Uh, at the very least, let me say peace again with leaving you again with this and like putting some musical background. Na 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 na.